So this is a totally different looking model of the atom than we had just been talking about. All of a sudden, instead of a big cloud of electrons that's just floating around at random, now they each have positions, and each of those positions corresponds to an energy, and they can transition between one energy and position and another. So let's talk about some of the terminology that you'll need to discuss those transitions accurately. Okay, so let's zoom in even a little farther. And let's zoom in just on this part right here. So we can sort of draw it as a line because we're zooming in so close. So here's n equals 1. Here's the nucleus at the bottom. N equals 2, n equals 3, n equals 4, n equals 5, and we'll draw n equals infinity at the top. Okay, so these numbers, first of all, this n that I keep writing, n is the principal quantum number. And that's one of the ways we describe the position of an electron in an atom. We'll talk more about these in the future. So the principal quantum number increases as we move farther from the nucleus, which is down here. We can also talk about the energy. And remember, we said that the energy was the highest farther away from the nucleus, and it was the lowest as we got close to the nucleus. And specifically at this point that I've drawn here at n equals infinity, the energy is going to equal 0 at that point. So it's going to start at negative numbers and increase to bigger numbers, but the biggest number energy you can have is going to be 0. So let's talk about some of the terminology we use to talk about these pictures. Sometimes you'll talk about whether an electron is in a ground state or in an excited state. So the ground state is the lowest energy state. And the lowest energy state is always the n equals 1 level. Wait for that to come back into focus. There we go, a little bit better. So the lowest energy state is the n equals 1 state. And remember, when we say lowest energy, we mean the most negative energy state, since these energy values are going to be negative. When we're talking about an excited state, we're talking about any energy state higher than the ground state. So you could be talking about n equals 2, or n equals 10, or n equals 500. Anything that's higher than n equals 1 is going to be considered an excited state. Okay, so these are the names for the different states. And we can also give names to the types of transitions between these states. So a transition can either be an absorption, which is also called an excitation, or it can be an emission, also called a decay. So let's start with emission, because we already talked about that one a little bit in the data on the previous page. So an emission or a decay means an electron is moving from high energy to low energy. And so an absorption or an excitation is the opposite. So in an absorption, an electron moves from low energy to high energy. And we can draw those processes on our picture, super zoomed in picture that we have over here. So let's say we have an electron in the ground state. If we want to draw an absorption or an excitation process, we want to move from that low energy state to a high energy state. And to move up in energy, that energy needs to come from somewhere. And so the energy comes from light. So we can call that a photon, a little light packet, or sometimes scientists like to write h nu to indicate this is a photon. So your electron absorbs energy and it is excited up to a higher energy level, up to n equals 2. If we wanted to draw a decay, we could put an electron here in the n equals 2 energy orbit, and we could say it decreases in energy down to n equals 1. And if it decreases in energy, that energy had to go somewhere because energy is not created or destroyed, so that energy is released. So we'll draw a squiggly line and we'll label that as a photon or as an h nu. So energy is never created or destroyed, it has to go somewhere. So if this electron is going to increase in energy through an absorption process, the energy has to come from somewhere. It has to come from absorbing a photon. And if an electron energy is going to decrease in energy, the energy has to go somewhere and it goes away in the form of a photon. So what sort of transitions are possible? Can I do a small jump? Can I do a bigger jump? Do I have to start at the bottom? These are questions I'm sure you have. So let's go ahead and clarify those before we finish. So which direction can the transition go? An electron's energy can increase or decrease. So in the picture we drew, you can move the electron up to a higher state, or you can move it down to a lower state. Either is a legal move. The transition does not have to start at n equals 1. And it does not have to end at n equals 1. It does not have to involve the ground state whatsoever. Transition does not have to start or end at the ground state. There we go. So you can transition between 2 and 3 or between 3 and 4. Does not have to involve n equals 1. The other thing you're probably wondering about is, can I jump more than one step at a time to get from n1 to n3, or do I have to take 2 separate jumps? And the answer is you can take any sized step that you like. So electrons can jump between any 2 orbits. They do not have to be adjacent. They do have to have enough energy. If you're going to make a huge jump from n equals 1 to n equals 5, you have to have a photon with enough energy to excite you that high. But as long as there is enough energy available, you can make a jump of any size. So this is the new view, Bohr's model of the atom as electrons in specific orbits with specific energy values that can be excited or decay in between those 2 levels. So we will have one more video where we talk about how to calculate the energy of those different transitions.